Hello there, everyone. Hi again. Welcome to mathematics class. My name is Miss Anne Opara. For those who know me, and for those who do not know me, I am Miss Anne Opara. Okay, so today's mathematics class, we're going to be learning about binary numbers. For some of us out there, this is our first time of hearing binary numbers, while for the rest of us out there, we are familiar with binary numbers, but we're a little bit confused about it. We don't really like it because it looks complex, it looks difficult. But trust me, like I'm going to give it my best to make it very, very, very simple. I'll do my best to simplify it as simple as possible. But trust me, binary numbers, there's nothing difficult about it. There's nothing complex about it. It's as simple as ABC. Easy peasy piece of cake. So stick around and trust me, after this class, you wouldn't have issues with binary numbers again, okay? So let's dive right into binary numbers. For us to fully or really understand the binary number system, we have to take a quick look at the decimal number system. Now, the decimal number system is our everyday number system. In the decimal number system, we have 10 digits that make up a whole lot of numbers. Now, those 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are the 10 digits that we have, and every number we have out there are gotten or formed from these 10 digits. Example, you can combine digit 3, 4, and 5, and that gives you a combination of 345. You can combine digits 6, 5, and 9, and that gives you 659. You can combine digits 6, 7, 8, 9, that gives you 6,789, and so on and so forth. So you can see that every number we have out there ranging from ones, tens, hundreds, thousands, 10,000s, millions, billions, they are all gotten from this 10 digits. Now these 10 digits, they are raised to the power of 10. So 10 raised to the power 0, 10 raised to the power 1, 10 raised to the power of 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on like that. So that is our decimal number system. Now let's compare this decimal number system with the binary number system. So the decimal number system, like I said earlier on, is a combination of 10 digits. It's made up of 10 digits, or it uses 10 digits, and those digits are 0 to 9. Now for the binary number system, it's a combination of just two digits. A combination of just two digits, and those two digits are 0 and 1. Full stop. That's all. So that is all the digits you have in the binary number system. So we have a lot of combination of numbers that are gotten just using those two digits. Remember that I gave us an example that we can have a whole lot of combination of numbers using the 10 digits that we have in the decimal number system, forming numbers even up to millions and billions just from 10 digits. The same thing applies with the binary number system. You can have a whole lot of combinations of numbers from just two digits, and those two digits again are 0 and 1. So that's just one difference between the binary and the decimal. So for your decimal, you have 10 digits. For your binary, you have two digits, 0 and 1. Now your decimal is raised to the power of 10, while your binary is raised to the power of 2. So far we've looked at the decimal number system and we've compared it to the binary number system. And we've seen that there's some differences, like the binary number system just makes use of two digits, which are 0 and 1. Now the 0 and 1, there's nothing complex about it. All you're going to be seeing is a bunch of zeros and a bunch of ones, different combinations. Now, the binary number system, the 0 and 1 is just like a light switch, which can be on, off, or it can be compared to things like yes and no, up and down, left and right, in and out, front and back, black and white. That's all there is to the binary number system. So 0 and 1, 1 and 0, yes and no, up and down, left and right, in and out, and so on and so forth. So quickly before we go into solving questions using the binary number system, let's understand something. Let's differentiate between a bit and a byte. A bit is the smallest unit of information, and it can have two values, which can be 0 or 1. 0 or 1. While your byte needs a combination of 8 bits to form a byte. Bits, small information, small unit of information, which can be 0 or 1, while your bytes is gotten from 8 bits coming together to form 1 byte. So 8 bits make 1 byte. So to make it easier, a bit is like a letter, while a byte is like a word. So your letters run from A to Z, while your words can be a combination of different letters, like EGG gives you egg. Okay. Alright, so having covered all the wordy parts and the talking parts of binary number system, let's get solving some questions, okay? Now, the first example, we are trying to change from binary number to the decimal number system. And we have 1010. That is a binary number system. So you can see what it looks like. So you can just see, all you're going to see just ones and zeros, zeros and ones. And here we have 1010. So we're trying to find out what 1010 represents in the decimal number system. Now, the first thing we are going to do is to create a table. After creating the table, we are going to fill in the table with our binary number. So the binary number given to us, we have 1010, and we're going to fill that into our table. After that, the next step is to assign the place value. So we start from the back, or we start from the end and move forward. Start from the back, move forward. Start from the end, move forward. Okay, so start from the back or the end, we have 2 raised to power 0, followed by 2 raised to power 1, followed by 2 raised to power 2, and followed by 2 raised to power 3. Now, 2 raised to power 3 gives you 8, so we write 8. 2 raised to power 2 gives you 4, we write 4. 2 raised to power 1 gives us 2, we write 2. And 2 raised to power 0 gives us 1. In maths, any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. So 2 raised to the power 0 is 1. 5 raised to the power 0 is 1. 1 million raised to the power 0 is 1. Okay? Now we've done that. So we have 8, 4, 2, and 1. Now let's go back to the binary number given to us. We have 1. Now 1 times 8 for the first column. Okay? For the first column, 1 times 8, 8. 0 times 4, 4. 1 times 2, 2, and 0 times 1 is 1. So we are left with 8020. So what do? We add the 8 plus the 2, and that gives us 10. So that means this 1010 is representing the number 10 in the decimal number system. It's as simple as that. But if you still don't understand it, just calm down. I got you. I still have another example. Let's quickly take a look at the second example. Now we have a bigger number, and the bigger number given to us, the binary number given to us, we have 1001101111111. So we want to find out what number does this represent in our decimal number system. So again, step 1, what do? Create our table. So we count how many numbers we have, and we create a table for just those numbers. After creating our table, step 2, place those numbers in your table. So we have 10011011111. The next step, step 3, assign the place value. Start from the end, start from the back, and keep moving forward. So from the end, we have 2 raised to power 0, followed by 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 8, 2 raised to power 9, and finally 2 raised to power 10. So 2 raised to power 10 gives us 1024. 2 raised to power 9 gives us 512. 2 raised to power 8 gives us 256. 2 raised to power 7 is 128. 2 raised to power 6 is 64. 2 raised to power 5 is 32. 2 raised to power 4 is 16. 2 raised to power 3, 8. 2 raised to power 2, 4. 2 raised to power 1 is 2. And 2 raised to power 0 is perfect 1, because any number raised to power 0 is 1. After that, we go back to our binary number given to us, and we start multiplying. So the first number, we have 1. So 1 times 1024 gives us 1024. 0 times 512 gives us 0. 0 times 256 gives us 0. 1 times 128, that is 128. 1 times 64, 64. 0 times 32, 0. 1 times 16, 16. 1 times 8, 8. 1 times 4, 4. 1 times 2 is 2. And lastly, 1 times 1 is 1. So we have 1024 plus 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1, and that gives us 1247. So the binary number over here is representing the decimal number 1247. So it's as simple as that. Okay, so we've looked at the binary number system, how to change from binary to decimal. That means how to change from ones and zeros to our 10-digit numbers. And step one is to create your table. Step two, put the binary numbers you've been given, put them into your table. Step three, begin to arrange the place value from the end, starting from 2 raised to power 0 all the way down. And then after that, get the value of each place value, and from there you multiply and then add and find your answer. As simple as that. So having learned that, this is a little exercise for you. So can you find the decimal numbers of this binary code? So we have 1010, we have 1101, we have 101011, and we have 1001110. So let me know your answer in the comment section, okay? So we've learned how to convert from binary to decimal. Now, how do we convert from decimal to binary? Because so far we've been trying to find out what the binary number system represents, like what number does this represent? So how about we find out now? We have 296. What is 296 in the binary number system? What is it going to look like from 296? What's it going to look like in ones and zeros? That's what we're about to do, okay? So this is very, very simple. In fact, this is the best part of binary number system. All you have to do is keep dividing by 2. Do not divide by 3. Do not divide by 4. Do not divide by 5 or any other number. Just divide by 2. So example, we have 296 and we want to find out the binary number of 296. Like I said, keep dividing by 2 and write out the remainder. So let's go. We have 296 divided by 2. That gives us 148, remainder 0. 148 divided by 2 gives us 74, remainder 0. 74 divided by 2 gives us 37, remainder 0. 37 divided by 2 gives us 18, remainder 1. 18 divided by 2 gives us 9, remainder 0. 9 divided by 2 gives us 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And that 1 divided by 2 is 0, remainder 1. Now, how do we write this number out? We focus on the remainders, okay? So you write down those remainders starting from the bottom. Starting from the bottom, you write it up. So starting from the bottom, we have 1, 0, 0, 1, 0, 1, 0, 0, 0. So that is the binary number of 296. So looking at another example, we want to find out the binary number of 1247. Again, divide by 2 and write out the remainder. So let's go. 1247 divided by 2 is 623, remainder 1. 623 divided by 2 is 311, remainder 1. 311 divided by 2 is 155, remainder 1. 155 divided by 2 is 77, remainder 1. 77 divided by 2, 38, remainder 1. 38 divided by 2, 19, remainder 0. 19 divided by 2, 9, remainder 1. 9 divided by 2, 4, remainder 1. 4 divided by 2, 2, remainder 0. 2 divided by 2, 1, remainder 0. And 1 divided by 2 is 0, remainder 1. So your division is always going to stop at 0, remainder 1. So what do we do to get our answer? Read from the bottom to the top. So let's go. 1 0 0 1 1 0 1 1 1 1 1. So that is the binary number of 1247. So having learned that, let's try this out. Not let's, you. I want you guys to try this out. So can you get the binary code of these numbers? What is the binary code of 2384, 537, 140, and lastly 63? So drop your answers for me in the comment section. So we finally come to the end of today's class, and I've had a lot of fun teaching you guys. I hope you had a lot of fun learning. Okay, so to quickly recap, we just learned about the binary number system. And when we started this lesson, we have to take a quick look at the decimal number system. And we said that the decimal number system is our everyday number system. Okay, the numbers we are familiar with in our everyday life. And said this decimal number system is made up of 10 digits, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And every number we have out there is gotten from the combination of these 10 digits. And we compare that to the binary number system, which we said is made up of just two digits, which is 0 and 1. And the binary number is just made up of just those two digits, 0 and 1. And we looked at how to change from the binary number to the decimal number, and from the decimal number back to the binary number. And we also learned about bits and bytes, that the bits is the smallest unit of information, which can be 0 or 1. And your byte is a combination of 8 bits. That means 8 bits make 1 byte. So these are some really interesting facts about binary. Now, the binary code is computer language. So your computers, whatever information you give to them, they always read it and interpret it in a bunch of zeros and one. The binary number system is the language of computers. And the binary number system was discovered by ancient Egyptians. Okay, and also if the last digit of a binary number is 1, it will be odd numbers, and if it is 0, it will be even numbers. So the binary number system is just like a decimal number system. Okay, so with that, we've come to the end of today's class. I hope you learned something, and I hope you find binary number system easy going forward. So see you in our next class. Bye.